Hello, everybody, and welcome to 7.1b. Today, we're going to talk about ratios and proportions and how to solve a couple different problems that you may encounter. So, first, let's talk about what a ratio is. A ratio is a comparison between two numbers. For example, 1/2 is a ratio. So an easy way to think of a ratio is it's just a fraction. So one, oh, that's way too big. All right, for example, 1/2. There you go. That is a fraction. That is also a ratio. There you go. There's other ways to write this. Some people could say 1 to 2. Okay, another way to write this would be 1.2. Okay, and then finally, you don't really write it this way, but I guess you could. Is 1 divided by 2. Okay, so those are all different ways to write a ratio. Proportion is two ratios set equal to each other. For example, this would be a proportion, like number 1. Okay, and we'll talk about how to solve these, which we already kind of did. So we're not going to go into too much depth on these. But let's do number 1. We'll probably do number 1, number 4, and number 7. We'll just ride the side here on these. All right, so we're going to solve the following proportions. And remember how you do these. Some people call it the butterfly method. Some people call it cross multiply. Either way, it's all the same in the end. And then I have to do 7 times 72, which is 504. Divide by 56 on both sides. And then we're going to get x equals 9. All right, we talked about this the other day, but there it is, just in case you forgot. Number 4, again, we're going to use the cross multiply or butterfly method, whatever you're used to doing. We're going to have 2y times 4y. I'll just put that right here because this one does get a little bit tricky. 72. Well, 2y times 4y, some people are just going to say it's 8y. Well, y times y is actually y squared, so that would be 8y squared equals 72. Now you would divide by 8. Divide by 8. Okay, then you're going to get y squared equals 9. And then how to get rid of this square is you must take the opposite inverse action of a square, which we all know by now is a square root. Okay, so we're going to have y equals plus or minus 3. Anytime you take the square root of the number, you're going to get plus or minus whatever you're doing. Okay, so. All right, and number 7, finally. Again, you're going to do the butterfly method here. You're going to get 3x plus 6. You could put parentheses 1 if you wanted to. Equals 2x. Don't really need to put the 1 because when you distribute the 1 here, you're actually going to get the same thing. Next, you need to get your x's to one side, your numbers to the other. This way I think would be the easiest way to do it. Either way, it's 2 steps. This way is just you don't have to deal with a negative negative variable. Yes, guys, this equation can equal 0. It's okay. The world's not going to end, okay? Now I'm going to subtract my 6. X. Oh, running out of space here. X equals negative 6. There you go. All right, let's talk about the word problems because that's where most of you are probably going to struggle. So we'll talk about how to do them. All right, Caleb is making a drawing of a bedroom. Sometimes it helps to like actually draw these things out. So Caleb is making a scale drawing of his bedroom. His room is 12.5 foot wide and 15 foot long. So I'm just going to draw that real quick. So we have a bedroom that is 12.5 wide and 15 long. This is in feet. This is in feet. Okay, that's his bedroom. On the scale drawing here, the width of his room is 5 inches. Okay. Okay. And then it's going to ask you, what is the length? Well, it is going to be X. Okay. So that's going to be X. And now we need to set up a proportion and solve for this. Here's how you do this. And this actually might help you with the previous assignment because I know we really didn't talk about how to set up word problems. So maybe this will help you. Anytime you set up a proportion, you're going to do one thing as it is to its partner, you could say. For example, if I'm setting up a proportion, I'm going to set the widths on the same side as the equal sign, okay? And then I'm going to set the lengths on the same side as the equal sign. Now, you don't necessarily have to do this, but what I am actually going to do is I'm going to transfer. I'm going to convert all these to inches because I like to deal in the same units. Okay, and how I'm going to do that is I'm just going to take 12.5 times 12. We've talked about this. It's going to be 150 inches. Now, most of the time, your units will be taken care of in the proportion, but I think it's just a good practice. Hey, if we're going to set up a proportion, let's get it all in the same units. Especially for these problems, I find it less complicated. So now I'm going to have 15 times 12 there, and that's going to give me 180 inches. So when I set up this proportion, what I'm going to do is I'm going to do width is to width as length is to length. There's multiple ways to set up proportions, but I find this one the easiest to remember. And remember, when I do big width to small width, I need to come back over here and do big length to small length. So you got to be consistent with how you set up these proportions, okay? So let's just do that real quick. So I'm going to have big width, which is 150, and over. And then small width is 5, equals big length, which is 180, divided by X, because I don't know the length there. Okay? So now that I set up my proportion, I am going to do the cross multiplication thing again, which is 150x equals 5 times 180, which is 900. Divide by 150, divide by 150. You're going to get x equals 6 inches. There you go. So x equals 6 inches. All right. Let's do another one. Okay. I am actually going to change this problem a little bit because I do not want to convert meters to feet and things like that. It gets a little like, why would you do meters and feet together? That's just a kind of confusing problem there. So I'm actually going to change this to feet. Okay. Okay. Just going to change it to feet. All right. Suppose a special effects team is making a model of a 996 wide tower used in a movie. if the model is, okay, and this is not drawn to scale. Obviously, this one looks like it's going to be taller than it is wide, but, you know, I just have to give you a visual here. And it looks like I don't know the height of the actual tower, okay? So what I'm going to draw this, I guess the smaller one, I will make it smaller. It looks like it is 9.2 feet tall on the model, and it is 6 feet wide. Okay, again, I'm going to set up a proportion, and I'm going to go width over width, height over height, in the order that I do it. So I'm going to go big to small, big to small. You could also do small to big, but you just have to stay consistent with your setting up the proportion. So here we go. I'm going to go 996 over 6 equals back to big, which is x, 9.2. There you go. Save a little time because I'm going to run out of time on this video. I know you know how to cross multiply now. I'm going to go ahead and skip to the next one. And this one, I really do want to talk about 12 and 14. I'm going to skip 13 because it's basically the same thing as 12. And talk about, you know, I don't know, talk about how to do it because it's on your assignment. The last 2 questions on your assignment look just like this. So please take good notes on this. The ratio of angles of a measure of a quadrilateral, and I'll try to do my best as a quadrilateral. Maybe it's a 4-sided shape that looks like this. It is 2 to 4, 4 to 6, and 6 to 8. What is the measure of each angle from smallest to largest? Guys, remember the interior angle sum of a quadrilateral is 360 degrees. So the best way I know how to tell you this is, and there's multiple different ways to do this one, but pretend that this is 2x, this is 4x, this is 6x, and this is 8x. And all I'm going to do is just set up an equation and solve for x. And where did I get these numbers at? Well, I got them from the numbers right here. It's a quadrilateral with this ratio. So I'm just going to set it up. It is 2x plus 4x plus 8x plus 6x equals 360. All right, I'm going to add up all those real quick, and I'm going to do this rather quickly because I am running out of time on the video. That is 20x equals 360. Divide by 20. Divide by 20. X equals 180. 18. It's 18. Yes, it is. So now find the biggest to smallest, or it says what? From smallest to largest. What I do is I plug in this x into each one of these, and I would say, hey, the smallest is 2 times 18, which is 36 degrees. And then I would go on and on until I had all of them in the correct order. All right, skipping on to number 14. And number 14 is one that you will encounter on your assignment. You have a rectangle that is 6 to 2 or 6 over 2. The area of the rectangle is 1720 square feet. It says, find the length of each side. Well, it tells you that the ratio of the side is 6 to 2, so let one of them be 6x, the other one be 2x. Remember, the area of a rectangle is length times width. That equals area. So what I'm going to do is I'm going to do 2x times 6x equals 1720. And that is going to be 12x squared. Remember, when I multiply these x's, it's x squared. And then it's going to be 1720 again here. I'm going to zoom in on this. And so I'm going to divide by 12, divide by 12, 1720, 1720, divide by 12 is a number. Wow, that sucks. That's a decimal. Okay. So I'm going to do 1720 divided by 12, and let me look real quick. Yes, it is 1720. Of course it is. And when I do that, I get x squared equals 143, 3 repeating. Take the square root of that, take the square root of that, and I'm going to have take the square root of this thing, this number, and I am going to be left with x equals 11.97, and then it's going to tell me to find the smallest and the biggest, or the lengths of the sides. I need to go ahead and plug that x in there and find the length of the sides. Okay, so that's the notes. You shouldn't have any problem doing the assignment. Do your best. I believe in you.